Today we're going to be talking about how to find the differential of the multivariable function. And in this particular problem, we've been given the function z equals e to the negative 2x times cosine of 2 pi t. And as a reminder, we're going to be using this formula here to find the differential of the multivariable function. Keep in mind that our final answer is going to be a value for dz that's in terms of x and t. And dz, the differential, represents the change in height of the tangent plane when we're dealing with multivariable functions here. Really, finding the differential is just as simple as finding partial derivatives with respect to the other two variables, in this case x and t. If we find the partial derivatives with respect to x and t, we can plug them into this formula here and get a value for dz. So let's go ahead and do that. Let's take the partial derivative of z with respect to x. If we look here at our function, if we take the partial derivative with respect to x, that means we have to treat t as a constant. That means cosine of 2 pi t, this whole thing right here, will just be a constant. So it's like a coefficient on this e to the negative 2x. Taking the derivative of e to the negative 2x, we get negative 2e to the negative 2x. That's the derivative there. And this cosine of 2 pi t just stays there as a part of the coefficient. So when we simplify that, we'll get negative 2 e to the negative 2x times cosine of 2 pi t. Now, if we take the partial derivative of z, this time with respect to t, we'll have the opposite situation where we treat t as the variable and we hold x as a constant. If we treat x as a constant, then this e to the negative 2x is just a coefficient here on cosine of 2 pi t. We can essentially ignore it for the purposes of taking the derivative of cosine of 2 pi t. For the derivative of cosine of 2 pi t, we'll have to use chain rule and imagine that cosine is the outside function, 2 pi t is our inside function. The derivative of cosine is negative sine. So let's go ahead here and leave this e to the negative 2x. That's just going to stay as a coefficient. The derivative of cosine is negative sine. So negative sine of 2 pi t. We leave the inside function completely untouched. But then we have to multiply by the derivative of the inside function. The derivative of 2 pi t is just 2 pi. So now when we simplify this, we'll bring this negative here and the 2 pi out in front, and we'll get negative 2 pi e to the negative 2x times sine of 2 pi t. Now we have our two partial derivatives. We can go ahead and plug them into our equation for the differential. So our equation is going to be dz is equal to the partial derivative of z with respect to x, which we already found to be negative 2e to the negative 2x cosine of 2 pi t. And we're going to be multiplying this whole thing times dx here. So we say dx. Then we add to that the partial derivative of z with respect to t, which we found down here. So we get negative 2 pi e to the negative 2x sine of 2 pi t, and we multiply that whole thing by dt. Now, as you can see, if we just simplify this, we'll get negative 2e to the negative 2x cosine of 2 pi t dx, and then here we'll get this minus, so minus 2 pi e to the negative 2x sine of 2 pi t dt. We can go ahead, if we want to, and factor out a negative 2e to the negative 2x, and what we'll get there is that multiplied by cosine of 2 pi t times dx plus pi times sine of 2 pi t dt. And again, we don't have to do that factoring step, but we can if we want to, and that gives us a final answer for dz, which again, remember, represents the change in height of the tangent plane.